Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. Today we'll continue to talk about work and the kinetic energy theorem. Here is an example. A 1,000 kilogram sports car is initially traveling at 30 meters per second. A frictional force F, defined as a function of velocity V, is defined as F equals negative 200 V acts on the sports car. The question is, what is the distance traveled by the car before it stops? So first, let's do a free body diagram. So the free body diagram looks like this. Okay. There's normal force, gravity, then there is the frictional force. As you can see, normal force and gravity cancels out. The net force is just frictional force opposite of V. To find the distance traveled by the car, we have to introduce x into this equation. So from here, we know friction is the net force. So negative 200 V is m, a is dv over dt. But in this equation, there is no x. So we have to introduce x into this equation. To do that, we can use v actually equals to dx over dt. Now, as you can see, dt and dt can cancel. From that, we can get negative 200 dx equals m dv. From here, we can integrate both sides. This m is constant, so I can take it out. X is moving from 0 to a specific distance. That's the distance we're looking for, big X, capital X. V, you started from 30 meters per second, then you come to a stop, 0. So we can do the integration on both sides. On the left side, we will have negative 200, the top minus the bottom, big X minus 0. On the right side, we have m, that is 1,000 kilograms, and top value minus bottom value, which is 0 minus V naught. V naught is 30 meters per second. We proceed to solve for x. So x is just m times V naught divided by 200, because negative and negative cancels. You will get 150 meters. Question number 2. What would be the frictional force on a car at 5 seconds? So in order to find frictional force, we have to find V at 5 seconds. So in this case, we have to use the first equation, V, as a function of time. Since we know the time, we have to find V. So we need to rearrange this equation to find V as a function of t. So in order to integrate it, we have to combine V and dV. Then the rest is just dt. This m is constant, so all this can come out. Do the integration. Time is from 0 to 5 seconds, and V is from 30 meters per second to a specific value, V. That's the V we have to find out. From here, the first one is just top value minus 0. This is a log, natural log 1 over V. So we know V has to be positive, so I didn't put absolute value around V, which should be absolute. So it's log V, top log V, top value is V, initial value is V naught. And this is really log V minus log V naught, and which is log V over V naught. And here we substitute m, this is the value we have. And simplify it. On the left hand side, we have negative 1. On the right hand side, we have ln V over V naught. We can do the e to the power of both. On the left hand side, we'll have e to the negative 1. On the right hand, we just get V over V naught. So from here, we can solve for V. But that's not what we're looking for. We're looking for frictional force. Then we have to substitute this V into the original equation, F equals negative 200 V, to find frictional force, which will give us 2,200 newtons. I hope it helps. If it doesn't, come to ask in class. Thanks.